In the last section, we talked about probability and simple probabilities. In section 5.2, we're going to talk about the addition rule and complements. So first, we need to talk about what it means to be a disjoint event. And a disjoint event, also called a mutually exclusive event, are events that have no outcomes in common. So for example, if I were to pick a number randomly between 1 and 10, there is no way that the number I pick could be even and odd at the same time. So even and odd in that case would be disjoint events, because there's no way to get a number that falls into both categories. So we need to talk about Venn diagrams also. A Venn diagram is just a pictorial representation of sets. So for example, if I have the sample space S and events E and F, and I need to draw a Venn diagram of those and then decide whether or not the events are disjoint. So first of all, we have S is 1, 2, 3, 4, 5, 6. And E is the odd numbers in that set. So that's 1, 3, and 5. And F is the even numbers. So that's 2, 4, and 6. So the way the Venn diagram works is we draw a big box, and that is our sample space S. That contains everything. Then we draw circles for E and F. Now if we look at our E and F here, we can see that E has 1, 3, 5, and F has 2, 4, 6. There's no number that's the same. So that means that when we draw our circles, they do not overlap. So if we label this one E and this one F, we're going to put 1, 3, and 5 in E, and 2, 4, and 6 in F. So are they disjoint? Well, the answer is yes. How can we tell? Well, when we drew them, because there was no element of either set in common, that means there's no overlap. And so, for both reasons, they're disjoint. Remember, disjoint means no outcomes in common. So let's take a look at a case where they are not disjoint. So since I just gave that away, we'll go ahead and fill in the no. So if we draw our S, and if we look at E and F overlap at 2 and 3, because 2 and 3 are in both of them. So we can say, if this is S, we draw our E, we draw our F. So here's F, here's E. So E is 1, 2, and 3, and F is 2, 3, and 4. Since 2 and 3 are in both of them, we put the 2 and the 3 in the section that overlaps. Since 1 is only an E, we put it in the part that's just E, where it's not overlapping with F. And the same thing for 4 in the F. Now, you might say, well, S also had a 5 and 6 in it, so what do we do with those? Well, since they're not in either event, we just put them out here in S. So in this case, E and F are not disjoint because they have outcomes in common. That's the 2 and the 3. So we'll scroll down to the next page here. We're going to skip B, and I will upload it to Momentum. So if you want to do it, please do. It is a good activity. It will give you some hands-on practice with this. You do not need to turn it in, but I will make a video going over it. But please try it after you finish the 5.2 lecture and before you watch my video on it. So the word or indicates that we should add the probabilities of events. So if we have two disjoint events, remember those are the ones with no outcomes in common, the rule is that P of E or F is the probability of E plus the probability of F. So for example, if we roll a fair six-sided die once, we need to find the probability of rolling a 2 or a 5. Well, that's the probability of rolling a 2 plus the probability of rolling a 5. Okay, remember a six-sided die has 6 sides, and there's a different number 1 through 6 on each side. So the probability that we roll a 2 is the number of sides that have a 2 on them divided by the total number of sides. So there's one side with a 2 and there's 6 total sides. Same thing for the 5. The probability is the number of sides with 5 on it, which is just 1, and we divide by the total number of sides. Now, you can stick this in your calculator, and let's see, I will clear out the last stuff I had. So in the calculator, we would say 1 divided by 6, that's our first fraction, plus our second one, 1 divided by 6. And if we hit enter, it gives us a decimal. If we want the answer as a fraction, we can hit the math key. And in this math menu, number 1 has arrow frac. That means turn the number into a fraction. So we go ahead and hit enter. Now you see it, this A and S means it's taking our previous answer and then it's going to turn it into a fraction. So if we hit enter again, we get 1/3. So 1/6 plus 1/6 is 1/3. Or if it asks for it in decimals, we'll say approximately 0.333. 3 decimal places is enough. Now, be careful in Pearson because most of the time it will tell you in the problem how many decimal places to round to. And if you round to the wrong number, it will tell you you're wrong even though you actually got the answer right. So be careful there. Okay, let's look at another example, this time using a deck of cards. And I've provided a picture of a deck of cards in case you don't know what's in it. So the important thing is there are 13 of each suit. The suits are spades, hearts, diamonds, and clubs. And there are 13, so each suit has 13 cards. And there are 4 cards of each type. So, for example, 4 aces, 4 twos, etc. So what's the probability of selecting a card and getting a heart or a spade? So the probability of heart or spade, now these are disjoint, right? Because there's no way that if we pick one card that it could be a heart and a spade at the same time. That's the probability of heart plus the probability of spade. And so there are 13 hearts, you can count them, out of 52 total cards. I guess we should have put that up there by our deck. 52 total cards. Okay, same thing for the spades. There's 13 of them out of 52 total cards. So again, if we pull up the calculator, it's always good to practice once more. I'll clear this out. We have 13 divided by 52 plus 13 divided by 52. And that gives us 0.5, or if we want it as a fraction, remember, hit the math key and then enter one more time. We get 1/2. So 1/2 or 0.5. Okay, let's do one more example, and that'll be the end for this video, and I'll pick up with the rest of this lecture in the next video. What's the probability of getting a jack or a 3 or a 9? So we can do this with more than just 2 things. So I'm going to say J for jack or 3 or 9. So that's the probability of a jack plus the probability of 3 plus the probability of 9. Again, these events are all independent, all 3 of them, because if you pick one card, there's no way it can be a jack, a 3, and a 9 all at once. So the probability of a jack is 4 out of 52, plus the probability of a 3 is also 4 out of 52, and the probability of a 9 is 4 out of 52. So if we type all that in the calculator, it's the same thing, just do this fraction plus that fraction plus that fraction. We will come up with 3 out of 13 as a fraction, which is approximately 0.231 if we round to 3 decimal places. So that's the end of the first part of the lecture on section 5.2. I'll pick up in the next video.